This is a question from theory of computation. Consider the following NPDA. We are having Q0, Q1, QFF, the initial states. Initial states. A and B as the alphabets. 1 and Z as the stack symbols. Delta represents the transition function. Q0 represents the initial state. And Z represents the initial stack symbol. Initial stack symbol. And QF represents the final state. And we are given a set of transition functions. We are asked to find out what is the language L that is accepted by this NPDA. So for one transition function delta Q0 lambda Z, we move to QF comma Z. This means that upon seeing or upon initial state or in state Q0, seeing an lambda input with stack symbol Z, it moves to state QF with the stack symbol as Z. This is state, this is input, this is stack. This is the basic definition. Now, one important thing to see is that this transition function and this transition function says that even with no input, it can make a transition. So from this, one thing can be inferred that strings of length 0 are also accepted by this NPDA. So option C and D can be eliminated because we are accepting only strings of length greater than 0 and not equal to 0. Now let's see how to solve it. Assume initially the stack is only having the start symbol, that is Z. Now initial state is 0. Now assume we are having this transition, that is in state Q0 the input string is A. Then what happens is we push two ones into the stack. Two ones are being pushed into the stack. Now next input is B. After this delta transition, Q0 moves to Q1. In Q1 we are seeing one more B. When we see in state Q1 1B and the top of the stack is 1, we simply pop that symbol and remain in state Q1. Then we are again seeing one more B. So since it is in state Q1 itself and B is the input symbol and again top of the stack is 1, we simply pop it. Assume this is the input string A, B, B. Now what happens is right now we are in state Q1 and now there is no more input and the top of the stack is Z. It moves to QF. So it has reached final state based on this transition. So this string A, B, B is accepted. Now let's see among options A and B which one is the string that can be accepted. A, B, B. It means that n can be 1 here. So A power n, B power 2n is the string that can be accepted. Here assuming n equal to 1, it can be A power 1, B into 2 into 1. So this means that A power 1, B power 2. That is A, B, B. So based on the options, we can say this one, option B, that is A power n, B power 2n, where n greater than or equal to 0 will be the appropriate answer. Option B is the right choice.